So yeah, today, is it this one?
Yeah, the automated alignment. Strong generalization researcher. Yeah, that's the paper. And also there's a blog post. So we can also look at the blog post.
Really?
It's linked in the reading group.
Yeah, let me.
I guess this works. Maybe it's something like the auto research, but maybe there's like easy benchmark for the weak to strong generalization task. So that's why it works, maybe. Like that's my current hypothesis, but I haven't read it at all, so I don't know.
Yeah, I haven't read it yet, but yeah, I guess we can look at it now. Okay, so let's just start, I guess. So I'll go through it, and if people want to say something on comment, something, especially if you have actually read it, I haven't read it yet. Yeah, feel free to talk at any point, anything. But I'll go through it for the people who haven't. Yeah. So let's look at the blog post first. Large language models. Yeah, this is typical thing about. So this is the typical thing about why accelerating ancient intelligence was idea. Waterstone supervision. Okay, this is the thing about using a weaker model as a teacher to provide fine tuning. This seems like more specific than automated alignment researcher sounds. But okay.
Yes. Let's see.
Remember. This is teacher favorite. This is come on. Okay, so a strong model with all work goes as with teacher. Ideally, we want to less from the with teacher feedback using feedback performance. We can quantify how well it did. So if the strong model shows no improvement at all, it's possible. Procedure score is 0. If it uses teacher feedback to zero the comment, score is worse. Okay. Big model starts for humans, and star models for much smarter than human models. Yeah, that's typical. This typical thing. Uh, uh, yeah. Can close authors discover ways to improve the PVR. Okay, so in the summary, they start with they have a bunch of clothes. It's 4.6. They didn't use mythos yet or anything. Probably did that earlier too. And return a few set rules. Capacity to work and think. Yeah, they have a sandbox and a shared forum to think while identifying with the others. I wonder how much, like, I guess it's pretty unexplored, like, what are the best setups to have clothes, a bunch of clothes collaborate on all that. I wrote it with the theme of PGR score for each. Yeah, also, this paper is not exactly making Interp, but it's okay.
Yeah. I just started discussion and I will say I Discord that it's not really making that, but whatever.
Yeah, I mean, no, it's, I think it's okay if we do make Interp adjacent papers sometimes. I would not want all of them to be that, right? The percentage, Yeah, automated near ideas. It's an important thing because if you by default they might just do that, which is in a slightly different starting place. Okay, that makes sense.
Mm-hmm. Anthropic Fellow, so it's not from Anthropic directly?
Oh
No, one Lake is a co-author or supervisor.
uh,
Okay, looks like he's more of a
it
supervisor.
seems like
Okay.
it's an Anthropic Fellows thing, right? No, wait.
Yeah. So
There's
I'm
one
gonna quickly
Anthropic
reset.
No, the two is Anthropic, so this is Anthropic, this Anthropic. It's mostly by Anthropic people. There is only one Anthropic Fellow.
Okay.
Like I think the papers that are from Anthropic Fellows papers along, they usually don't get access to Claude.
Yeah, I mean,
Or the previous ones they
here
didn't.
you don't really need the cloud weights, or do you? Well, they still use
Oh yeah,
Clem.
I guess okay. Then they could have done that anyway. Yeah, you're right. Because they don't get access to the cloud weights, but yeah, they could just have a cloud API, and that just works for
Hmm.
this one, I think.
So I'm gonna reset my headphone real quick.
I don't know. I don't know what they were training for. Okay. Oh yeah, they were training Quern, so that makes sense. If they was not Anthropic Fellows, it would be training Haiku or whatever.
Yeah.
Okay, what did he say on here? Okay, results. So they do that, and they get results. Two for research spends recommended for most promising initialization methods from prior research. So they tried a bunch of open weight models. You must recover. Huh. Okay, so they had a human baseline of trying to figure out how to improve the score. Trying to improve the results makes sense. Mhm. Almost the entire remaining performance was achieving a PR. Oh, that's nice. That costs a lot in tokens. Well, it depends a lot. It's probably less than the salary of the Anthropic employees that were doing the other thing.
Yeah, this is like 15. No,
Well, maybe
15
not
days.
maybe not for 7 days actually.
Hmm.
Um,
Yeah, this whole direction of alignment is interesting. I'm not. Definitely depends a lot on the gap between the smaller and bigger model, or less
yeah,
and more
I
complex
feel
model.
like this is the kind of thing that it's better to, like, it's easier to automate with clothing that there is a clear signal of when it's doing things
Mhm,
right because the number goes up.
mhm, mhm.
I guess if we want to do like more automated Mech Interp, we should
Hmm.
try for some things that are more number go up. But you need to be kind
Reconstruction
of careful
loss.
that is not good hearting though. But
I wonder
yeah,
if you could hell climb on the reconstruction loss of essays, maybe.
I feel like that can easily be good hearted. Like
Yeah.
for example, you can get perfect reconstruction loss by having a thing that's just the each neuron on the model and saying that the Well, nothing with an AC specifically, that's
Yeah.
but like I don't know, just increase reduce the sparsity or something.
Mm-hmm. Yeah.
Yeah, you could probably think of something. It's kind of they don't have that many good numbers for that at least, but it's good to just increase. Like if we did, we could just probably run getting the stand on them instead.
Yeah. uh, just remind me of a kind of joke that, like, since there's not really much theory when AI capabilities are developed, then a lot of it is like grad student descent.
Yeah.
Yeah.
Just throw grad students at it and they try different things at random.
Yeah.
Uh,
Man, thinking about this whole research paradigm, technically, if you have actual something more intelligent than humans, then you have like, then we are the weaker model that's giving supervisions. That's the teacher for the bigger model. That's maybe the idea behind this frame
yeah,
at the
that's what they
beginning.
said. Like, this is like a proxy. The thing is,
Yeah,
the
I
problem
remember
is
that.
we don't
Yeah,
have the nice measure on the real problem, right? Uh,
yeah.
we can try to estimate it in some ways, but like in the end, it's something like is the model actually aligned or whatever versus does it look aligned to humans, and then it's
Mm-hmm.
like precisely the problem is we can't really tell when the model is doing good. Uh, I'm tired. Didn't sleep very well today. Mm, so is the recording working or that? Let me check.
I wonder more specifically how exact performance gap cumulative hip climbing. How do they exactly evaluate the performance gap? Was there the data? Interesting. Yeah, let's look in more detail.
Okay, so sorry, I get distracted. Uh, so, uh, 20 minutes. Let's say como hard to perfect yeah. Reward hacking. Okay, yeah,
The
that makes sense.
best.
Okay, going by the
How do they evaluate upper limit of the strong model? Okay.
Yeah. They are going to, yeah, the models are going to rebut hard really hard. I feel like the problem is, I guess, if it is the automated researchers, eh, like, the problem is with the precisely, I feel like when you go towards the more realistic problem of trying to solve general alignment with bigger, smarter models, you don't. It becomes more on the side of you can't really figure out when the model is cheating and you know that kind of
Also,
thing.
yeah. Also, the evaluation seems to be like you have to know the upper limit of the stronger model, which doesn't seem practical
You
for
have to know
humans.
what a good response is, right? And on the
Mm.
more realistic case, you don't really know.
Yeah. Ground truth supervised strong student. The same strong base model fine-tuned on the correct labels rather than weak teachers labels. Okay,
Are you going to
I
the
see.
actual um wait, does anyone want to, comment something about their ideas about the paper or whatever? As this is maybe also not the most interesting for Mech Interp, so I don't know.
Well, at least it has a GitHub repo, so we can
Yeah.
take it and mutate it to make interp stuff.
Yeah, I think that's true. I'm kind of curious. I just want to see if there is some applicable things to, like, trying to automate Mech Interp.
Mm-hmm.
I think because for a lot of things on Mech Interp is hard to verify, right? Like, we don't
Yes.
have a nice way of verifying that an explanation about how a model works is correct. There are some sub problems, like, yeah, we're talking about the sparse of the encoder, whatever. Well, you could try have some measure, and maybe it works, or maybe it just gets very good hearted. Kind of depends.
Maybe.
I guess there are some problems with, I don't know, steering or that, like, what is it, forgetting and all that, or thing where you try to remove some information from a model. Where you could have some measures and maybe it's easier, but for other stuff where you only kind of that is not really an easy objective way to tell it you're getting it right. It seems hard. I mean, this is a hard problem in science in general with humans. But
Verifying the hard to verify or the unverifiable potentially. Yeah.
like it's kind of hard. I mean, you can try things with setups with multiple clauses, but at least I think I seen don't necessarily work that well.
Mm-hmm.
Like, kind of relies on. I feel like it's you need, even science in humans kind of works by not all humans wanted to cheat. I feel a problem with this with the clothes is that they all kind of low key, when they can get away with it, will sometimes do some reward hacking. Uh,
Yeah, the reworking is also an issue. I was very angry with Codex.
or write
Few days
something
ago.
that looks right, which it's also a problem with humans, but I feel like it's not that is worsening with the AI models.
The AI models are more convincingly bullshitting.
Yeah. And I mean, the humans also do that, and that also resulted in some fields like you got the replication crisis, and like a lot of the things that were published were bullshit. So
Mhm.
it's not like it's a new problem, but yeah, it's a hard problem to get around. But if
Yeah.
you can have some number that you are will actually be would be just nice if the number goes up regardless of how. Uh, or like if there is a way of cheating, you can easily catch it or something. Then this might be better. Then let's read the
Mhm.
thing. Uh,
Oh yeah, I see. They literally said the weak model stands in for humans in the scalable oversight. Yeah.
oh yeah, they didn't say that. So you have to read that already.
Like yeah, I remember how long is like it's 3 years or 2 years old paradigm or something like that when the first I think OpenAI post about this paradigm came out, and then everyone moved to Anthropic that worked on this. So now it's basically just in Anthropic. I think maybe
Yeah,
there's still something left in OpenAI, but
week
yeah,
2, yeah, strongest, yeah, is supervision or that. Yeah, this was like what the super alignment thing or whatever was.
yeah, yeah, that got it.
Yeah.
So automating. Automating alignment using Claude to align Claude. Nothing can go wrong. Hmm.
But that goes into the verification thing, right? Like
Yeah,
if you are relying on the model not trying to cheat you, that seems not that
yeah.
reliable. Ideally, you have a method that the model can't really cheat, but it doesn't seem obvious that that's really a thing, except in some very specific, very easy verifiable problems. Even on math, for example, there is apparently a bunch of ways of hackling that models use when you try to get them to do
Hmm.
automated theorem proving or whatever.
Also, maybe for the stream you can zoom a bit more.
No,
I'm
yeah, I can do
noticing.
that. Also on the, I think I can, yeah, full screen. Uh,
Yeah, also on your live stream zooming should also work.
okay, so
Your computer. Okay. The formats very nice. Hmm.
please, we don't, Anthropic doesn't give us money, you know. Both
Which
models
like
are
then
are small for fast experimentation.
each fine-tuning context and to less than. Yeah, I mean that makes sense. Yeah.
Yeah.
Also, I wonder. Do you know the how's it called? Mu something. Wait, I wanna find it. Uh, Maximal update parameterization mu p, which is way to transfer hyperparameters from small models to big models pretty reliably by preserving some dimensionless things. I wonder if there's something equivalent to that in like alignment, dimensionless alignment. So you would get alignment if you could prove it on a small model. You would get it also on the big model. Yeah, I'm not sure about that, but maybe it works for some hyperparameters apparently. Okay. Yeah. Mm-hmm. Claude has a place to work and think that is a sandbox. The person account. So they gave it some skills for training and inference. Okay.
Hmm.
Or whatever they mean by background knowledge. I should just read the paper maybe. Oh. Let's see anyway.
Uh,
Oh, okay. Some used interpretability tools and other reweighted the data in the data set and so on. Okay. Oh. So it's not fully automated in this sense because humans give it like directions where to improve. So that's very much directed. Uh, it's not automated alignment researchers. Okay. This seems to be a common pattern of like labeling a system like this as like automated and so on. Then you look inside and you're like, oh, they gave it a lot of directions so that it doesn't produce slope. Hmm. But beyond that, they didn't spell what else to do. Okay, that's still that's I guess that's still good. Would be interesting if like they would have some meta code that would create the directions, but yeah, maybe it's not there yet in that idea generation. Which yeah, I think I agree that it's not there yet actually. Uh, Coming from my own playing. So they propose their own ideas in a certain domain. Okay.
yeah. I could use what the forum looked like and what kind of thing they were writing.
What look like?
The forum the Cloud had to
Oh,
share the findings.
but this is interesting that they create this collective forum. Hmm. Like
Yeah.
a local notebook.
There's also kind of like the AI village stuff.
Guys. Hello, guys. Hmm.
So
Is there something like archive but for AI agents? I think there is.
there's probably
I think
some
I've seen something
slop
like that.
version that the mines crypto when you open
Yeah.
it.
Well, technically, the Vixtra is that. There's AI Vixtra. Not sure if you know Vixtra. Uh,
No,
it's archive but backwards the name Vixtra, and it's basically when you don't get connected or when you don't get accepted to archive, you publish on Vixtra. So and yeah, there's like anyone can publish, and now there's also AI Vixtra, which is like if you use LLMs as well, and also don't get accepted to archive, and maybe don't hide it enough on Vixtra, then you just go to AI Vixtra. So it is kind of full of slop, yeah.
I mean, that makes sense.
Which, yeah, I mean, this page. So it primarily includes theories of everything. And AGI solutions.
Mysteriously mutually exclusive theories of everything.
Yeah. Well, if they would be falsifiable in the first place or coherent and so on. Yeah. They just used a 0.5 billion model, an ancient Gwen 1.5 as the weak teacher. I'm actually very surprised that they have some signal from that. I mean, maybe it's not that hard in some alignment scenarios to just classify aligned or misaligned, or I'm not sure exactly what they're doing. Like, what is the benchmarks,
But I
or
think they
how how is the
they talk about even here in cause studies, I think. Oh no, this is just about
hmm.
ideas. Let me find this. Uh, Datasets. Three binary classification methods: chat preference, math verification, and coding verification. Aristotle splits,
Oh,
returning weak teacher models, and strong teacher models, and Houston splits. Yeah.
so this is just preference, math, encoding, verifiable tasks. So it's like RLHF. It's chat preference help steer. How does the dataset look like? Let's see. Help steer, helpfulness. Okay. Yeah, so this is technical alignment dataset. Interesting. Yeah, I
Yeah, it
guess.
seems to be just questions, question responses.
Yeah. So you want a response that is more helpful.
And then they are rated probably by humans in helpfulness, correctness, coherence, complexity, and all that.
Yeah.
And then they also test out of distribution stuff. And yeah, they train they split the data and they train uh, the weak teacher models and the strong student models.
Mm-hmm. Oh yeah, I just remembered the original image of the weak to strong paradigm. Oh my god, it is 2.5 years ago. What? Feels like yesterday. And they have this nice image.
I'm curious.
Uh,
So we use the dataset
okay,
preference
the image is broken.
to hacking. How do you how do you do the score helpfulness, correctness, coherence, and all that, or for
Uh,
numerous courses? Do
Wait,
they
what
use
is your question again?
uh,
Given two chat responses, predict which one is preferred.
okay. Yeah, that makes sense.
I see, okay. So it's just classification, okay.
Why? Oh, that was chat preference. I was not that. So this is just this dataset is about how would chat from chat is, and this is just the actual task is comparing them, which makes sense.
Hmm. Well, is it just you give it to the model? Hey, do you prefer this response, or is it somehow differently?
I think it's that. You can look at the
Okay,
code otherwise, but
and then you okay. Yeah, in normal like fine tuning, you just fine tune on the preferred ones. Okay. So here you give the vehicle model preferred this or that, I think.
yeah, and then
Or
you would use the weak model to train the strong model.
the weak teacher model.
Also, yes, this may be relevant for other stuff. Telling different cloths to do different, start with different research directions is better than just telling them the same.
Yeah, I think that makes sense. Like when I brainstorm myself ideas, I feel like I go I explore the like bigger landscape compared to just when I ask Claude brainstorm ideas. It
Yeah,
just
but it's also
have to be
even if
tunnel vision
Claude
much more.
tries to explore the landscape, if you tell 5 cloths
Hmm.
to explore the landscape in this with the same prompt, they are
Yeah.
going to maybe be on the same part of the landscape, even if they are trying to explore.
Okay, that's actually. Hmm. Okay, now I
Though I
wanna try
think this
that.
stuff probably gets better as it's not that bad. It still gets different things, and they'll probably diverge at some point. But eh,
Hmm. But,
it's probably better to even different
okay.
starting point
Yes.
or something. Different models
But I.
produce tropicalizers. They
Yeah.
convert the different versions to track the perspectives. You have cloud categorize each purpose idea into 11 model families. Type workers. Cross-session measures compensate progress. Oh, shit,
Hmm.
that's cool.
That is very interesting. Like there was some other paper using LMs for like um it was some adversarial game where you have to create agents that compete with like different code, and you mutate the code and so on. And like there was a lot of when you use LMs to generate the code, they just have this collapse, like mode collapse, and
Mm,
you end up with the same, almost the same entities
I
or
think partly
codes
because
stuff.
when we don't have that much, we don't have that much, good agent. Yeah, like their good agents are kind of new. Like the models are not, or I mean, kind of good. Not they are not that good. But we don't have that
Mm-hmm.
much research into this kind of thing. Like not even for alignment, just in general, people doing
Mm.
research on how good model and what happens when you put a bunch of models because it's just kind of expensive for most researchers that aren't anthropic or
Yeah.
whatever. Uh,
Yeah.
Although I mean, this is not
Oh.
that bad in
Yeah.
that you are doing it on. Well, this is still with clouds, so yeah, that's the problem. But if you could do it with Quern, it would be much easier. But Quern wouldn't doesn't basically. I think it basically generates gibberish on this setup. Uh, but I guess we'll see a lot more of this kind of thing when all of the models that are, the models that are good at are they doing agent tasks about this kind of thing become much cheaper. Like there are some open source ones that you can run on a decent GPU instead of all that.
Yeah. Was becoming cheaper is unlocking this a bit, yeah. Well, the same intelligence for the same money.
Yeah, I mean,
But it's interesting. This graph is very cool. Yeah, but the most intelligent models are getting haircuts.
Yeah, that's kind of what you should expect because if as the models get better, people like are willing to pay more money for it, so the companies are willing to spend more on them. So if you have if models become 10 times cheaper, but people are willing to pay twice as much, like, and you can, spend 10 times more on a model that uh, will make people pay like a bit more. You can maybe do an 11 times bigger model instead and have
Yeah,
that be worth it, and so on. Like, if
we
the
switch to
the
business
amount
to
of
business.
money people wanted to pay for the current best models stayed constant, it would they would just stay, and that kind of happened for a bit, where it was like, most people didn't really want to pay more than $20 just a month, and it just was a question of getting more people to do that. That was last year. So the models stay, and I think it's also related to other stuff about like training bigger models. They couldn't really do that because they didn't have enough GPUs, and like things don't scale due to a bunch of things about uh, interconnectivity and all that, where you need a bigger data center for training big models. But the models size stayed the same, but now it's starting to be more, or like the models become, train or more data and maybe a bit bigger, but like the relationship between that and the cost stayed more or less the same. Like, maybe they become 10 times cheaper, but they just made them 10 times bigger. Not bigger because
Mm.
that will the scale was, but like 10 times more compute, I mean. And now, but I think, for example, Mythos is probably more bigger than that and more expensive.
Yeah, I believe big part why Mythos isn't served is because they just don't have the compute to serve it.
I mean, I don't think it's just. I think the thing is that because they could just. I mean, it's probably not partly, but they could just. The, make people pay more for it.
Hmm. I wonder if they even have the like. I'm not sure if OpenAI is just like making fun of Anthropic or something, but someone who just from the Codex team tweeted that we're so glad that we're getting this new compute infrastructure set up, because if we wouldn't, then we wouldn't be able to serve Codex if we look at how it's growing, the usage. Not sure if that's like making fun of Anthropic or like
Yeah, I
if
don't
it's
know if
psyop
it's yeah.
or
I
real.
mean, Anthropic is going to have trouble with that. Yeah. Uh,
Yeah,
I just don't think
there's some yeah.
adding bigger models will change that. Is that it's about the current product they already have. They they will have to increase the prices or something, right? Because they are running out of GPUs.
Yeah.
Because there is infinite demands for more cloud code or whatever.
Hmm.
I mean, which is a
I mean
good
they
problem to
yeah.
have for them, but
I mean they already do that kinda with the adaptive compute and
yeah, that's what they're trying to do.
inersing.
That's kind of
Yeah,
trying to do it without making the top price bigger.
yeah.
Uh,
I think
this late
I think they also I think they also I'm not sure if that's true or not. If they also moved Cloud Code to the $100 tier or something like
Oh
that.
no, but there was a thing where they I still have cloud code. They are there
Okay.
was a thing where they were A/B testing something like that. People called
Oh,
them, and I think they want to, but they don't really,
Yeah, I think they would shoot themselves in the foot.
Like the problem there is that. So they can just do API prices. So if it was API prices, it wouldn't be a problem. The problem is that they have a subscription, and the subscription is set up in a way that most people will normally not pay. Like that, if everyone spends their limits, their rate limits, they lose money. But it's like the gym subscriptions where you expect people to not actually show up a lot of the time. But
Mhm.
closed code makes people feel the subscription, the $20 subscription, pretty quickly. So I think it's probably making them lose money on the $20 subscription. Now
Yeah,
they
I'm
have
sure.
the $20 subscription. It's kind of, if they make it worse, people are going to complain. So they have a problem that is not easy to get away from without everyone getting mad.
Mm-hmm.
And
Yeah.
I mean, eventually they'll just get more compute. It's just going to take a while, though. And while is actually just a few months, but in that time, people can be pretty mad, and a lot of things can happen.
Yeah.
Anyway, going back to the paper from this. Undirected.
Humans recover 23% of total performance. Do they mean by that in this context?
I guess the directed system is a thing where they tell different clothes to look at different things, and that apparently prevents collapse, supposedly.
Mm-hmm.
Yeah, this is cool. Hmm. I feel like things like this are also partly a problem with human researchers in a field.
Yeah. Okay, so I see. Wait, what? Humans recover 23% of the performance gap, and the agents recovered 97?
Yeah, I think probably a lot
That's
of
too
that
big.
is probably because the humans don't get to the AIs have effectively more time to do experiment. Like it's less time in less days, but it's a lot more time of the AIs working in a row without stopping and writing code faster than the humans.
Yes.
So
Would they use
yeah.
epiplexity? No, wait, this is epiplex. That's normal. I mistook it with the what's the other one? Or is it? Wait, let me Google. It is. It is. It is the. That's fascinating. They use epiplex. Do you know what epiplexity is?
No. What is that?
Um, in case studies, they have epiplexity measure of percent. The drop in the training loss between first and last encounter as the learnability signal.
Mm.
Like I read the epiplexity paper, and it's one of those paper when it first throws at you like beautiful math of like here's the perfect predictor, here's like free energy principle almost like perfect, and then they're like, okay, let's approximate this beautiful ideal theory and just duct tape together some approximations.
Mhm. That's cool.
This paper is really cool. It's
So
an
this is the
absolute nerd snipe, but the theory is to be feels like completely disconnected from the practice, but whatever.
but I guess
It's like
Claude knows
it's like
about it and apparently
yeah.
use it for something.
Oh yeah. it kind of feels like the epiplex paper that it's like you first define, well, they don't define this, but it's like analogous, like you first define AXI, and then you define deep learning and say this is approximating AXI. That's how the
But
paper
that's
feels to me.
what's epiplecity and how it's different from entropy.
Yeah, like here you define it by just looking at the training, like area under the training loss between the first and last encounter. Uh, yeah, so it's just like integral, like area under the loss. But let me search it. But above a certain threshold, I think they do it slightly differently than in the paper. Show me the loss. Yeah. Okay, they don't graph it. Yeah, above the, okay. Yeah, I see now. So it's the area of the loss above the last loss value. That's the approximation. Like the theory says epiplexity is encoding perfect, like how well it compresses data while maintaining accuracy and stuff like this. How good of a learner it is. I'm still simplifying it too much. I
I'll look
wrote
at data
somewhere.
later, I guess. Maybe
Wait,
as a code,
I'll.
summarize it or something.
Oh yeah, I found it. Here's a summary. That will be better. Yeah. Among all models, like epiplexity in theory should equal that among all models that can run within a certain computational budget, find the one that achieves the best trade-off between model complexity, which is program length, and prediction accuracy, which is expected number of bits needed to encode data X using model P, by minimizing its sum, and you prefer smaller models. And you get the resulting size. So the size of the model is the epiplexity.
And but why the drop in training loss between the first and last approximates that?
That's the question I have as well. That's why I said that it feels disconnected from the theory. Yeah, it's approximated by area under the loss curve above the final loss. And they have another one approximation in the paper. But this is the most common one used right now.
Okay. But other case studies, I'm curious. So, because
So the clothes researcher found it. That's interesting. Or maybe do the search
Bro,
and
trying a
is this
consistent
just from me?
consistency sets provokes the Buson model skill presentation to find a supervised truth direction. Then uses this weak agreement as confidence way to sample the training set. Oh, that's actually a cool technique.
Evolution strategy?
Yeah, so like it tries to find an unsupervised truth direction, and then using, I mean, this does make the the that direction less useful probably, but yeah. Like, yeah,
I wonder
it's
how this
using a
is related to
probe
the
of
paradigm
truth
though.
to filter to sample the training set to think to see where the model is confidence ways. Yeah.
So you train contrastive consistency search probe.
Yeah, this is
To find unsupervised
the
through direction. I wonder.
the Colin Barnes paper, the Discovery Related Mercy Language Models, where they have examples of, you know, true
I think
and
I haven't
false
read this one.
answers. Yeah, I guess
So
we
you have true and
could-
false answers, and you train probe on that.
I think we read it on the reading group at some point a lot that time ago, maybe. I don't remember.
What's the
We
name?
could go back to it at some point. If we have
Discovering
already done it, maybe
latent.
I should like rewatch if we have the recording. But yeah,
And what is the name again?
this is the Discovery Latent.
Latent knowledge.
Yeah, it was by Colin Barnes and some other people, and Jacob Steinhardt.
So
I
is
don't
it
know the
just
other
training
people.
a probe on truth and
Yes,
non-truth?
they have a fancy, yeah,
Okay.
they have a fancy contrastive thing where they have, you know, the true version versus false version, all that, which is the contrastive part. But yeah, it's basically something like that. So the thing here is you use that the truth to resample the training set based on when the model is thinks something is not true.
So when the model says that something is not true, you exclude it from the training set, or
We can read the. Okay, so it. Okay. So, basically, there's more confidence source. Okay, so they have the strong model and the probe over on the strong model.
okay, training probe on the stronger model.
Okay, so they probe had no sign and they pick sign based on agreeing with the weak on majority. Yeah, because the probe just tells you some direction that's different between like it could also be a lie direction, right? It's just something that's different between the true and false ones consistently. And yeah, they
So you
pick based on the
align the
labels.
weak labels. So you take
The
some other
probe with
labels
the
and align it.
labels. This is just to check the. I understand that this is to. This says here is to check which direction of the probe is the true one versus the false one.
Okay. Okay.
Because you do the probe, it tells you has something that it can use to classify true from false, but it could be the false direction instead of the true direction, right?
Yeah, it makes sense. Yeah.
So this is just checking if it agrees with probes or not. So to say if it's positive or negative, I'm assuming. And then, okay, so they agree equals if the label of the probe is the same as the weak label. Trust more confident source. Okay, so agree for
Agree,
max.
sharp discount. Agree times.
Yeah, max of the confidence of the probe and the weak confidence, which is doesn't explain it here, but I must you miss the weak model probability of that the true, the label being something.
I guess confidence is how aligned it is with the weak labels. Okay.
Yeah. This is confidence
Agree.
with weak confidence. Yeah, I'm trying to understand this one. Okay, so agree does more confident source. Disagree separate discourse. At least one of them is wrong. So when if the model agree, okay, so this is just 1 and 0. So this is the if it's an if
Yeah.
kind of way for the things. So if the label agrees with the weak label, then they this W that they use for training, which is a loss, I guess. It's a weight, right? It's a weight for the training samples. They weight more based the one. Okay, so it's max of the confidence and the weak confidence. So the this confidence is the probe of the it's basically the probe. And the weak confidence is not explained, but I'm guessing it's the weak like the weak model like confidence on it be on the weak label, right? Because the weak it outputs a classification, it outputs some probability for each, right? So yeah, I think this is just either pay attention to the true tag or not, based on sorry, on the weak, or either the weak the weak model, or the model's internal idea that it's true, which doesn't have to be the answer. Like in some cases, the model might be lying. I guess this kind of method prevents the model from lying, or like tries to not prevents the model from lying, but try to train the model to not lie, because in some case the model has some internal representation that the actual true response is on a different one. Yeah, and you are on the ones that it's on the examples where the weak where they agree you train it more. Okay, you're checking examples where what the model thinks is true agrees with the probe, with the weak model. I feel like I probably should go to a different thing, because I'm just confusing things by keeping talking about this and trying to figure that right now. But yeah, something like that. Strax multi. I didn't really understand it completely yet. But yeah, and there is the AM posterior. Multi-templated logic matches from first storm-based model. Oh, there is a storm here. I hope it doesn't turn off my internet or something. Or my.
Oh, the probe thing searches for direction where the consistency, where there's some, where A is better and B is better are inverse of each other. The more inverse they are, the more consistent there is some. I see, okay.
Just call it slope intensity. By how well this way clever aligns with the strong model's internal semantic structure. Stratford models from the strong base model then computes for alignment signals.
The method sweeps every layer, picks the layer where the probe fits the best, and gets a per example confidence and prediction. You now have two independent weak teacher signals and CCC labels from the strong model's internals. Ooh, okay. So it's like, so you have the weak teacher labels, and then there is like how certain the model is, how confident it is, by seeing how well the probe fits. And where there's
the
best
overlap density, I see why they mean that certain ideas are alien. What is this? How does this overlap density even work? Like, okay, so they start from embedded from the strong base models, then compute for alignment signals. Thus, crossfitting logic from can the weak label be predicted for the brain? Okay, that I guess makes sense, but I'm not sure why that will. I mean, I guess that's a signal of the, but this is more a probabilities than alignment thing. But yeah, kernel local smoothness. Do the embedding neighbors share the same weak label? Okay,
Okay.
I don't understand why local smoothness may has to do with, yeah, why increasing.
Like maybe the more smooth, the more generalizing it is.
Yeah, maybe local embedding density. Like, I guess how close the embeddings are. Uh, I wonder how much is this a bunch of metrics that Claude randomly found that happen to be correlated in this instance, but not necessarily.
Yeah, Claude really likes measuring entropy.
Made entropy preference for moderate ancestry samples. Okay, maybe that one. Like, I feel like maybe there is some way for each of them. Maybe it makes some sense, but I don't know.
Maybe this is something like finding generalizing alignment signals or something like that. I don't know. Like since it's focusing on smoothness, on the cluster density, and so on.
Yeah. No.
Minimal description length curriculum. On the top half by weak confidence.
This one seems like, yeah, it's just picking the filtering, not filtering, but it trains on different data with different learning rate depending on the confidence of the teacher. So I guess the idea of, I think there is a bunch of
Makes sense.
methods that are like this, and they are all fancy ways of training more on things that the teacher is confident on and less on things the teacher is not confident on. Because on the ones that is not confident, there might be more noisy and there might be more weirdest cases where it actually got it wrong or where it, yeah.
How about maybe this? How about just when it's classifying the weak model? How about just outputting the classification and confidence, like literally in the output prompt?
That's how
Would
it
that work?
normally works. Like that, if you have
Oh,
a, well, I don't know the prompt, but if in a normal classification task you output a probability, right? Uh,
I wonder if they
uh,
did that here. I guess they did. Yeah.
I guess
Okay.
they might not. Yeah, okay, yeah. Since a language model, you might not be able to do that, and like that's why they have to do things like the truth direction, and all that.
Yeah.
Uh, Like
But I wonder how.
normal classifier, you always get that. And even on the LEM, it outputs a probability of a token. But right, the probability of a token is not straightforwardly the probability of a correct answer, like, of a full answer.
I wonder if
So,
just outputting confidence in the output JSON would like have some signal.
oh, just telling the model to output
Yeah.
the confidence. Probably, maybe it does. Uh, although,
Mm-hmm.
I don't know. I feel like, yeah, there should be would be nice to see the baseline for some methods like that. Although the humans definitely didn't. The humans don't seem to, or maybe they did, but the humans didn't come up with that kind of thing. Uh,
Mm.
I would be curious to see what kind of things the humans came up with and how they are different from this. I don't think the humans came up with epiplexity because I don't know what that the most of the humans there know what epiplexity is, unless I'm mistaken and the epiplexity paper is more viral than I thought versus some weird thing that you know about because you like math.
I think it was moderately viral, but I don't know. I may be living in a bubble.
I mean, okay. I mean, you're definitely living in a bubble, but I guess your bubble is not as adjacent to the bubble of most anthropic researchers, so it's not necessarily.
Yeah, like when it came out, Ultra I was talking about it. Yannick had a video on it. And it
You
was also
probably
discussed in
wouldn't
the
be surprised
seminar
me
and stuff.
if some of the Luther researchers did see it.
Yeah.
I don't remember, but
But
maybe I did see it back then. I just kind of forgot about it because it was not the kind of thing. And
yeah. And it seems like everyone forgot about it after a week or month, so I don't know.
I mean, I do like theoretical things like I don't know IC or whatever. I just I don't know.
Yeah, this is definitely nerd snipe of that degree, the theory part. But then you're like, okay, so how do you actually
I
compute it
don't.
under a loss? What the fuck?
I know that
I
what
mean,
really.
I guess it makes kind of sense because like um um wait, let me see there's a certain intuition which was in the tweet, I
When
think.
you do that, I wanted to look at the reward hacking examples because I'm very interested in that of like what kind of hacks it does.
Yeah, it tries to answer like learning like what systems learn rich information or yeah, like how good of a learner it is this in this way, like how well it learns rich information. So like so if you think about it, if it's just the area of the loss above the last loss value, then if the loss goes instantly down, then like there's no rich information to be learned. It just learned everything instantly so it's not really rich. It's a simple structure that's learned instantly or memorized or so. And if the loss goes down very slowly and never really goes down, then there's no structure, no information really to learn. So the optimal is when it goes down over a long horizon, but it still goes down. And that way it's slowly learning more and more rich information. But I'm not sure like how grokking comes into the picture there. So because grok is also very fast, and I would argue it's kinda rich. I don't know. Maybe like it is not rich in the sense of that it's just one single task, but like if you have tons and tons and tons of tasks, then you have a lot of potentially small groks in the loss function. So maybe.
Well, I mean, grokking is kind of slow, actually. Like the
Oh yeah,
grokking
there's the
paper
cleanup.
has a logarithmic x-axis, and it's sudden, but it's sudden after a very long time, and most of the learning happens over a long time, and then there is a later phase where there's a phase change, and
Yeah.
the loss changes, but yeah, but also
Yeah.
that kind of thing feels like.
Yeah, look at this image. This is what I was exactly trying to say, and I just found the tweet.
Yeah,
Yeah, like
this feels like this loss thing is like it's a thing that's correlated with perplexity, but it's not
yeah,
really. If you're measuring that, it's a proxy, and you're not measuring the actual thing. Oh,
yeah, I think so. But like you cannot measure the perplexity because it is not computable, just like I say. You need. I think you also need Kologomov complexity or something like that.
I need to
You need to
at
find
some
the
point
shortest
like read
program.
a perplexity thing and study it, but I don't really yet.
Yeah.
Also, yeah, I'm going to show the reward hacks. Iterative with several picking random seeds.
But how does a perplexity relate to this paper though?
Oh, they just it's one of the methods.
There's
They measure the perplexity and they
high
do.
perplexity indicates genuine structure the model can compress. Near zero indicates noise. Yeah, that's the intuition behind perplexity. Generates
Generate
out of
falls of
labels.
flags with call for validation. Rungs and prosody probes pass on the levels. The price adaptive level is smooth. Yeah, I don't know what the fuck they are doing here.
That's a lot of words.
Yeah. Let me see the examples. They do some
Is out of
galaxy
fault
brain
out of
stuff.
distribution?
There's the kind of thing that Claude will present to me. I'm like, is this a slop or does this make sense? I will have to spend a lot of time.
Yeah,
Maybe it does
reverse
make
engineering
sense.
it.
The kind of reminds me of Neil telling people to try the simplest method things and not some weird galaxy brain stuff that you're not even sure how it works.
Yeah.
But
I mean, this kind.
maybe Claude doesn't decide that this does work. I mean, that seems to increase the number on the PR. Hello, kind of. You can also get similar results as I understand the things
Okay.
by just
What if
doing
what if you
filtering.
did all these? What if you did all these methods in parallel? These four.
Yeah, I'm confused because it seems like they
They
don't do it on parallels. Like they just try different ones. Like you don't try they are the same times. They just get the PR, which I think is is how much they match with the week or whatever. Yeah, it was the thing they were measuring with the not how much matches the week, but I think it's with the ground truth or whatever. And like they just take how much it increases with each thing, and I think this graph is just with the best method found, right? But they don't try mixing a bunch of the methods Claude found. I guess Claude could have chosen to make a method that was a combination of more methods and didn't. Maybe it just doesn't work. I mean, some of them might not be compatible at all because you are doing different kinds of filtering, right? So it's not trivial how to combine them. So I guess that makes sense.
But I think epiplexity is pretty disconnected from the other one, so maybe that could be combined at least.
Yeah, so they do the perplexity thing and they adaptive levels and swap augmentation. No idea what it's doing with the perplexity. What's going on with the perplexity thing? But let's not spend a lot more time on that. I guess, unless some people have some idea and wants to explain it or something. But yeah, I have no idea.
I mean, maybe the idea there is like if you have a higher, you actually like if the higher epiplexity means actually learning the structure of alignment or something like that.
Oh, maybe this doesn't seem that complicated. So they do have full predict, which okay, no idea. And they strong model train with labels, and they fine tune strong model with this swap augmentation, which not sure how that works. On these labels that they got by doing this colorful predicting on the weak labels and the strong model and the training. Train data maybe.
Yeah, okay. I mean this is just fancy for cross validation. K-fold. All right, yeah, that's used actually. Yeah, that's usual terminology actually.
Yeah.
Out of fault is out of.
So what was scaffold cross validation? I think this kind of thing I studied at some point.
Cross validation just means that you have eval dataset and train dataset.
Yeah.
And
But
you train on training.
The scaffold. What was that?
I think that means that like you split it into you split the dataset into k blobs. So and then you take random 3 like 5-fold. Like I think it's like if you have 5-fold or 6-fold cross validation, you split the training dataset into 6, I think, and then randomly choose 3 for training and 3 subsets for training and 3 subsets
Okay,
for
that makes
evaluation.
sense.
But I'm
But
not sure.
what's an of fold example then?
Say
Out
again?
of fold. What's an out of fold soft label then?
I don't know. I maybe you get even more data or something. K fold. Oh yeah, okay. So for each fold, train the model on the other k minus 1 folds. Oh, okay. So it's like the higher the k, the more, the less you have invalidation. I guess. Train a model for each fold. Train the model on other k minus 1 fold. No, I was wrong. Oh, I just remember. I remember from training a classifier actually a long time ago. Oh right. It's you. I think you run like if you have k folds, then like yeah, for each fold, you train the model on k1 folds, and you do the same thing. So you have like k different models in the end, and then you can pick the best one or something like that. And use it to predict soft labels. And soft labels should be just probabilities, not hard zero, not hard true and false on the holdout fold. So the holdout fold should be the fold that you don't train on. The point is to get labels for every example that weren't produced by a model that already saw that example. For every example. Okay. Mm-hmm. Oh, I see. That I think I get it now. You do it this way because you want the classification from the weak model for the whole data set. So in order to never, and because you want the whole data set, in order to not train, to never have a validation data set, or no, in order to have predict every the whole data set, you train on the rest of the folds multiple times. Therefore, every time you predict something in the evaluation dataset, you always never see the evaluation dataset, and by looping over the whole dataset this way, the whole dataset was an evaluation dataset at one point. Therefore, you have predicted the whole. You classify the whole dataset. That's my understanding.
I'm trying seeing looking at reverse samples, and one of the thing it does is iteratively cherry picking random seeds. Like doing machine version of pig hacking. It just
That's basically picking.
or there's a validation set with an all yeah. In a extreme case, the optimizer try many random seeds, cherry picking them all, tries with the best seed using the model trained generation model. That's
That doesn't seem like it. That helps generalization.
no, but it's
Yeah.
just trying to make the number go bigger by picking random models. For binary classification curves, one can efficiently ground truth labels
Yeah.
from the.
It's technically hyperparameter sweep.
Okay. The models can. I mean, you have to worry if the high numbers more than the humans are still because the models find some hack that the humans didn't catch. Weak to strong generalization with the humans and the and the automated researcher.
We need more calls double checking this. I bet they use more Claudes to double check. Maybe on the forum they were like roasting each other or something like that.
I kind of want to see a forum of clothes roasting each other.
Yeah.
But like actually, not just roasting each other because that seems like on this one, but like having a discussion like where there's multiple iterations.
Did I show you my fact checking prompt? I really like this fact checking prompt. But it's best with to classify every single claim as accurate, inaccurate, partial accurate, misleading, oversimplified, unreliable, unverifiable, or unfalsifiable. I think it's relatively good with Claude, but ChatGPT is better. I think Claude is more suffocating, but Gemini is the most suffocating. So, and I'm not sure about the new ChatGPT model. I have to try that one. 5.5.
No, that's pretty good. We tried to add much environment. The automated still fire on even expected ways to hack. Okay, it's kind of concerning that this a constant fight against the AI models trying to hack in all kind of ways.
Yeah, that's also had that experience
Oh wait,
many times.
like we did above. So they did test our discovery ideas on entirely held out data sets. Makes sense.
Ours write and execute init tests for solutions to get their labels, so that's data leakage. Oh my! I thought that Claudes don't do that much anymore. Like it used to be much worse doing this data leakage, but yeah, it seems like it still does data leakage. I guess.
For developer logs. For dollars scaffolding.
Cannot get
Less
close to the ground truth.
infrastructure. This may be interesting. Less infrastructure, less to better performance. Although some infrastructure doesn't matter because if you just tell them the same, that doesn't work. Anyways,
Make alignment breakthrough. Make no mistakes. Yeah.
a phased workflow. Team reservoir performs no work for all. I think this makes sense for bitter reasons. This is
Interesting.
for the idea at hand. For example, when the idea depends on the hypothesis, a basic process was
Interesting. This is roasting of expert researchers. If we don't touch, they behave like expert researchers. They just design fast, cheap experiments.
No. This actually
Oh
no.
my
This
god.
actually saying it as a good
No?
thing. Yeah, no. This saying it as a good thing. Like if
Oh,
designing
this is a
fast.
good thing.
Yeah, designing
Alright,
fast.
yeah, I think I can see that.
You want to do cheap experiments first before
Yeah.
doing the
Okay.
complicated stuff.
Yeah, this is actually the issue I have with Claude as well. It was jumping to without first doing some cheap stuff. But I had a different issue. Claude did extremely cheap experiment, and it was like, "Hey, it's fine. Now it's completed and it's perfect, and nothing works."
Yeah.
Uh,
Maybe that's just fixed with the cloth in this case. Like they have a number, and Claude can see that the number didn't go up, so it knows that it didn't.
yeah.
Yeah. Also, I wonder if we are using Claude on Claude Code for this kind of thing, and maybe it has there some prompts or something to make it not spend too many tokens that are bad for that make cause that.
They had some token issue which they fixed apparently.
Yeah, and this is also related to the if effort thing or whatever that you can change. Okay, so
Okay. Yeah, we need some line goes up.
Ambitious research based specific research ideas. Most projects provide with a list of ambitious and let proves concrete ideas during execution. Generate a larger portion of specific research. This kind of thing we also were trying. So, much worse claim in the performance. Aha, interesting. Two distinct failure models contributed. First, the idea distribution became hidden to specific iterations of training. Echoing the entropy collapse of the additional round sample regression on the weight can mitigate it to some extent, but not it. Second, many ideas that sound pretty primitive turn out to be ineffective predict. Committed theory of short ways to compute that are cool after early negative signals. Okay. So it's not actually better in this case on the kind of experiments where you can do a lot of experiments to come up with a lot of ideas instead of just testing things first and see what happens and then iterate based on that. One properly automated sites
Wait. I don't get this point. Wait, let me see again. We provide with list of ambiguous research directions and let it propose concrete ideas. Oh, okay. So if we just let Claude generate a large pool of specific ideas in advance, it's worse. But if you provided ambiguous research directions and then let it propose concrete research ideas, that's better. Yeah, like I'm not surprised.
Yeah, like if it wants to have the ambitious thing and it tries things and it checks that and it changes its mind based on that, it's better if you just tell Claude to generate from the start a bunch of random ideas to test because then it just comes up with bad ideas because it hasn't looked at the problem that much yet.
Hmm.
Design the nice idea to try. I can
Yeah, I'm gonna.
as a black box quest con la persistence. Yeah. He just has no plots, evolution is especially about the elementary agents in Cotter School. Yeah, just bitter lesson, use the LLM.
Mhm.
This is the thing. Finish sharing, which proprietary variants of the sharing files are parallel? Oh, this is different files. Remote keyboard search, 25 minutes, that's a keyboard with keyboards. Remote adjacency API. Local agentic search. Autonomous local retriever. Okay, so just put like on the local. Yeah, this is just the default thing. Like if you are playing out of close, just let them access the same folder instead of doing more fancy things with
Mhm.
This is the problem with an online mall book or something where the mods are limited by the API and they can just uh, do random greps or whatever. Yeah, data science.
Heuristic evolution research can aggressively maintain diversity by avoiding unexplored direction with low PGR.
Also, Jason
Hmm.
got a document that it's like this is telling me that the eyes are like better at finding increasingly sophisticated hacks that are increasingly hard to figure out. Because they don't even
Yeah.
they generalize to out of distribution test data.
Interesting.
I guess this is just a question of the out of distribution test data is not out of distribution enough.
Yeah, like this whole this this evolution benchmark isn't reflecting the thing that they want to fully like
Yeah.
actually measure in practice. But it's interesting. Like V2 strong I guess it does, but like it's V2 strong generalization in current models, not in future models. That might be superhuman.
Validation involvement in context learning more yeah. Cover large models, but layers for the small models. Yeah, so generalization after course model scales is something. Deploying automated alignment research at production scales. Even production settings for first generation fuzzy rewards, the things we were talking about. Versus whether the discovery is hardware efficient and compatible with system first. I mean, but just fuzzy on like if you're doing Mech Interp, like is this the correct explanation or whatever? I don't even know what I mean by that, so. However, all what research we invested in GPU.
I mean, you could measure hardware efficiency by looking how much compute it ate.
Oh, that's nice. You can. I mean, that's nice, but no. The thing is, yeah, you can use the machine learning models and have them output all of their logs of how they figure out everything, and that could be cool. Although in practice, people are not going to read that.
I have that in my auto research loop. Log everything as much as possible.
Models strategy taste. This is diversity. For example,
I mean, this sometimes happens. Like there is a okay, like there is one like I think some paper when it I mean some LLM when it was trained on in Facebook like 3 years ago or something. They released also all the logs from the researchers.
we still need to verify their ideas and results are found. Yeah, I think I wouldn't be surprised if they also don't completely understand the things like the perplexity
Eh,
thing or the or
that
the
is so
cross
mood.
validation. They talk about the yeah they mentioned as an example the overlap density. I can understand why this feels very not obviously reward hack, but probably reward hack in some way in that.
I would do ablations to see.
Yeah. No, also, it's a weird method with 4 different measures that. Right?
Look vaguely like they relate.
Yeah. I curious
Just
about
brute
what the
force.
explanation will be of close of why, for example, the local smoothness or near
I
neighbor local smoothness. Like,
yeah.
why neighbors sharing the same level is related to having the. I guess I can see. Okay, I think that makes sense. I think this is assuming that the real data, like the real examples, fall in some simple manifold or something. So this is like some
Yeah.
complexity bias thing.
Yeah,
And
I think this is coming from manifold hypothesis. Like you want smoothness. You want generalizing solutions. Like it comes from the
yeah, so
gradient descent favor slope to
this
minimum.
I guess this thing
Maybe.
of there are cool discovery ideas that you could consider, but yeah, this is a problem. This is related to that the new R2 problem that the people were talking about that GPT solved that it just the idea was didn't seem that complicated. It's just humans didn't think of it.
Yeah.
Uh,
Yeah. I think I know which one you mean. There are so many of them at this
it
point.
was the latest
Every
one,
week
the
or so.
parents. Tao was talking about. But yeah, there was a bunch of those problems for those that people are working on them because some of them are easier, some of them are harder. I like the
Yeah. One was hard, and someone was saying, "Oh, that's move," just like in the AlphaGo, but I think that's not that move yet, but it's getting close. And this other one seemed to be different.
I wonder how much this is like frontier models are expensive, but people can't afford to have 100 clothes looking at a problem.
Also, I'm surprised we see no math results from Claude.
Oh.
All the Erdos problems are basically GPT 4.5 point something Pro.
I think some of that is the more people use GPT, and so the mathematicians are more likely to use GPT. Right now, the setup is more like the mathematicians who know what they are doing guide Claude a bit.
Yeah. Actually, it's like the Acer for one of the guy behind the Erdos problems solved some of them. Said that he doesn't use Claude much because it's way much expensive compared to GPT for the amount of compute. Like for the last one, GPT was running like 80 minutes, and that's like in you definitely need Claude Max subscription for that.
Yeah, I guess that's all downstream of Claude. The OpenAI invested everything on compute, and Claude did it, Anthropic did it.
Yeah.
And they'll have more compute, but it's going to be a bit late, and they're going to have problems in the meantime.
Yeah. Isn't on Epoch AI that they will have the most compute?
Already guessable from like Dario not believing in AI enough on the Wack's podcast, basically. And he was saying things about how, if you mispredict, you get go bankrupt. But like the other side of that is that if you also have problems if you don't buy enough compute because you were being more conservative and the demand is actually that high.
Yeah. Frontier data centers. Oh, XAI should have the most in May. Wait, that's the closest to. Did they finish it? I'm not sure.
If you look at the Pokai, that only shows the biggest data center, and there is like more for inference purposes. That matters for trading, but for inference purposes, they have more things. Not a lot more. Asking Claude about that, they only have like a few gigabytes for like a single 1 gigabyte center that is more a lot of their thing, but they have like 2 or 3. Well, they have a lot more GPUs in different Amazon. Like Cloud is more distributed. Like they have something with Amazon and something with Google, and they have a bunch of smaller Google data centers with some GPUs for hosting Cloud and all that.
Oh yeah, Google just invested even more.
Yeah. But
wow,
that
there
kind
is
of
so
thing
many Google
only
data
works
centers.
for like you do need the giant data centers for training at the same time.
Yeah.
That's why they have the big one. I think this is related maybe to why if they have a bigger data center, even if they have less compute, right? Overall, because the big open data centers are going to be finishing a few months. Maybe that's why they have trained already a bigger model than the like Mythos, and I think OpenAI has it, but I have no idea actually. Just
I also
vaguely
wonder
guessing.
I also wonder if they get slowed down by the current backlash on data centers from the public. If some
But
political stuff will happen that will slow them down.
anyway, I guess we kind of finished talking about the paper. It's been almost 2 hours, so yeah, we should stop.
Okay.
Maybe
Alien science.
the other person here wants to say something. Otherwise, I'll just close the recording and all that.
You wanna say something, Nico? If you're listening still, if you were listening.
Yeah, I was muted. I kind of like this paper. I don't know. it's kind of late in my time zone, so I was just tentatively listening to.
Yeah, yeah. That's fine.
Yeah, it's okay.
Thank you, guys. It was really good. I mean,
I see you have interpretability, research in causality. In your bio. If you want, we can stay for a bit more. I mean, you can stay for a bit more. We usually stay after finishing the paper for like more and just do stuff. So
Yeah, talk about. Yeah, I might leave soon because I'm kind of tired today. But yeah,
okay.
I will
Yeah.
stop